This video is going to be just a crash course on Roboguide. We're going to go through all different types of things. It'll have a title that matches what we're going to talk about and multiple different titles to go with it. So we'll look at this program. One premise that we have of this program right now, we're just creating some generic loops. The other thing is for a premise, if you go to data, you will see the registers menu. If you don't see registers, you might have to hit type. Make sure your shift key is off, hit type, and then click registers here if you're not on the screen already. But we created a couple of register descriptions here, just pallet 1 and pallet 2, full pallet 1, full pallet 2. And so register number 2 and 3 will be number placed on the pallet. So we're going to use these as counting registers. So we will basically increment every time the robot does a place to pallet operation. And so there's 2 pallets. So that's why we're placing to pallet 1 and then we're placing to pallet 2. Then we have the full pallet 1 and the full pallet 2. Now the reason why we're doing this is to have a hard set number that we can assign to what is a full pallet, but also it's to show an example of utilizing registers. So, and to try to give an example of like what a register is and like what the purpose of a register is. That's like one of the biggest challenges with all this is like figuring out like what's the purpose and use case for these different tools like registers, digital inputs and outputs, group input and outputs, things like that. And so like in this instance, we're calling a full pallet 10, a stack of 10. So we'll stack, let's say 10 high, and then we'll move over to the next pallet and stack 10 more. Maybe we'll write a program that does something similar to that. Oh, so to delete a instruction, you have to go back to your line number over here. Then after you're on your line number, now you can go and change your teach pendant screen to edit command, delete. So go ahead and go back up to this if statement right here. So one of the thought processes with this if statement was we're looking at how many pallets have we placed, or how many numbers of parts have we placed to the pallet, and then we are saying equal to full pallet. So notice like the full pallet we set as a 10. And so one thing that could be done differently here is that this register 4, we could have just said equal to 10. So we could have said register 2 equal to 10, jump to label. But we didn't do that. And part of the reason why is it's not always the best programming practice, and you kind of have to determine when's the right time to do certain things. In this particular instance, we're using the register 2 equal to register 4 to demonstrate the utilization of a register. And then to give another real-world example of why you may do something like this, is you might have somewhere else in another program writing what a full pallet is. So you might somewhere in another program have a PLC saying, this is the recipe value for this part number that we're running. Maybe you have boxes that you're stacking. It may be different sizes boxes. Maybe the big box you only stack 5 of them. Maybe the medium-sized box you can stack 10, and maybe the small box you can stack 20. So the PLC passes that information. You know, operator sets on the HMI, I want to run part number medium box. And so part number medium box is then told to the PLC. The PLC then passes a 10 for the full pallet amount. So we're just pretending that this value came from a PLC. And let me just write a quick example real quick of what that would look like. So this is like very useful, and you would definitely utilize something like this. Now a lot of times you do this in a different program. You wouldn't do this in the program that we're doing it in. And you just do that just for programming practices. So we're going to insert some lines, 5 lines. And Gene, I'm just going to do this demonstration, and then I'll let you take back over again. So we're going to use the I/O. Notice in these I/Os you have different types of I/Os, digital outputs, robot outputs, group outputs. By the way, that's the icon mode versus non-icon icon mode. Icon mode is like a newer user interface for the FANUC robot, but almost all robots utilize this standard menuing system.
What is it for?
It's just a different layout. One's more of like a push button style, and the other is more of a just a menu system. They're both menu systems, but this one's like just a more generic version. But this is what I'm used to programming on, and this is what every single FANUC robot will have this exact same menuing system for like the past 30 years. There might be stuff missing there, or there might be additional stuff now, but it's pretty much the exact same layout. Versus the other one, something that just got released. I mean, maybe it's been like 8 years now, but I still don't use it. So we're gonna go over to instruction, then we're gonna go to the I/O. And if I'm not mistaken, this may not be available in some of the older programs, but this is now available as its own separate instruction. So register is equal to group input. So instruction, I/O, and then we will go down here to the register equal to group input. So a group input would be what's utilized from the PLC. I won't say that you can't directly write to a register, but it's a lot less common practice. In almost all applications, you don't directly write to the registers. You write to a group input, and then you pass that group input data to the register, which is exactly what we're doing here. We have our full pallet amount, which is 10. So a full pallet amount is on register 4. And I'm pulling this information from right here, and over here in our data menu, register 4 pallet 1 full. Going back to our program, select enter. And then here, we're gonna set this register. This register should be 4. Yep. And then this group input, I'm just making easy number's sake, and you should try to do this as much as you can in your programs, but we'll make a group input 4 as well. So you should create as much alignment in your programming as possible. You know, a lot of times in programming, you'll program in like increments of 10s or 5s, so that way maybe you start at like register 10 will align with like your group input 10, and that way you can have code that relates to one another in a relatable area. Or even if they can't be in the same, how do I call it, like data numbering system, because there's already something there, you at least want to keep all your data that's relative to one another close to each other. So if you go, what I mean by that, to give a more clear example, we use 2, 3, 4, and 5 all as our pallet place data. So that's pallet 1, pallet 2, pallet 1, pallet 2 data. And we have it all chunked together. You don't want to like put like full pallet like way down here at, you know, line number 27 and then put another one here. You don't ever just choose random numbers. You always just select a number. Either you start at a 10, you go like 10, 20, 30, 40, or you can do by 5s. And you kind of also will do this depending on how much data you think you'll need. If you know that you're going to have, like let's say for instance, perfect example is if in this instance I'll say, okay, we only need 4 data points, so I'll only allocate 5 data points. So what I'll say is like this section, I'll only need 5 data points, okay? But let's say for instance we're talking about pallet 1 and pallet 2 here. We had 10 pallets, right? So we have 2 data points for each pallet, which means we need a total of what would that be? We had 10 pallets, it'd be 20 data points. So we would know that we need 20 data points of space. So if I started at 10, we would need to allocate all the way up to 30. Meaning, it means don't put anything else in between 10 and 30, because we're gonna need that for our 10 pallets that we have, if we're just pretending that we had 10 pallets. So this is like a data organization thing, and it's extremely important to have this in mind while like creating your programming and creating your data structures, like the way that you can create your data structures is to identify the different parts of the application. So if you have a place pallet, how many place pallets do we have? Okay, we have 2. Do you have a pickup position? How many pickup positions do you have? 1 or 2. And then you can say, how many sensors do I have, or how many? And so this helps you, like, you write all this out on paper or in a document or whatever, and then from there you can kind of start distinguishing, oh, I'm gonna need roughly this many data points here and this many data points there, and you can create your data structure in that way. Back to the program, so just select and then CK program. Okay, here we are. So register number 4 is equal to GI4, okay? I'm gonna go back to data. Notice we have it set to a 10. I'm gonna just do this for testing purposes. We're gonna go shift, step, forward. I guess we'll do a quick IO setup real quick. So we'll go to the IO menu, type, group, yep, IO, type, group. So IO menu, go to type.
Oh, okay, so that's why I did the type.
IO menu, yep, type. So we're inside the type menu, and then we'll 5 for group.
Okay.
I'm not gonna expect anybody to know this, but like, I just happen to know I can do like rack 1, slot, oh wait, hold on, I think I got that backwards. I think it's rack 89. Slot 1,
What is it?
start point 1, number of points, 16. I can't really explain to you what I'm doing right here because there's a lot that's going on here.
So where you get that number 89 from?
My brain, memory. But so I'll tell you, when I say rack 89, what rack 89 means, it means Ethernet IP.
I got you.
Okay, so that means the robot is going to talk to a PLC via Ethernet IP. Okay, and then, so these numbers are a hard set number. FANUC tells you if you're going to talk to it via Ethernet, use rack 89. Another time where you'll have different rack instances, I don't know these off the top of my head, but like an input, like if you had a physical input card that had wires running into it, or a physical output card and had wires running into it, those have their own rack number. So if it's an input card, I'll just say a random number, it's rack number 5. If it's an output card, it's rack number 6, like that. And also, I had to refresh my memory because it also, the rack number for the cards that are actually on the robot might be based on where they're actually slotted at in the rack, potentially. Or the physical rack itself might actually have its own number, and then you just change what slot number it is. So you'd have like a physical rack that's in there, like of a PLC basically. It's like PLC I/O, but a little bit different. You might have a single rack number for that entire rack, and then you would say what slot number. So like if it was an input card, you may say slot 1 here, and then the next one would be slot 2, next one would be slot 3, next one would be slot 4, okay? And then you're saying digitally, where do you want to assign this at? Meaning, how much memory of the computer do you want to take up, of the robot's computer? And where should it start at? So if you just said we're talking about a number from like 0 to infinity, I'm telling it I want to start at 1, right? And then how many number of inputs do we want to use? We want to use 16. And then like, let's say for instance, for the next one, how I would do this one would be 89, slot 1. I might get this wrong because it's been a little bit of time since I've done this. So it wouldn't be a start point of 1 anymore. It'd be a start point of, the reason why is because this is consuming 16. So we're starting at 1. It's going to consume 16 points. That means the next one has to start at 17. This one will also consume 16 points because it's group input data. So the group input data needs to be either an 8, 16, 32. I think it can only go to a 16 though. But yeah, so that should be set there. So we don't have any set here either, so I'll just do the same thing. 89, slot, oh shoot. Slot 1, start point 1, number of points, 16. And if I'm not mistaken, we're going to have to cycle power the robot after this. 89, slot 1, start point 17, and it's 16 points. Not positive. So you have the ability to cycle start your robot from here. Function, go over to this menu system, 8 cycle power. This will cycle the power. This will cycle power. Are you sure you want to do this? Yes. So it's going to cycle the power of the robot as if it were a real robot. You turn the controller off, turn the controller back on. Yeah. Cycle the power always means to turn it off, turn it back on. Yeah. So basically we're just going to change this to back to what it was. So full pallet 1. I'm going to do something kind of silly just to kind of do what I was trying to do, but do it extremely generically. We're going to say option keyboard GI2 sim. So the reason why I did this is because we're going to act like this is a group input. Because really there is no difference in the way that these really act, at least at a surface level, and we'll do GI3. I did GI2 sim and GI3 sim, again, to match our register 2 and our register 3. So I'll go back to the program. Again, since I can't use this GI, we're going to change this GI back to a register, and then we're going to use my GI2 sim. Okay. So now, when we run this program, which I'll just run a quick test, shift, let's go look at data first. So you see our data, we have 10 and 10 set. Okay. So back to our program, shift, forward, okay, go back to our data. Notice one of our 10s got shoved to a 0. Because down here, our register 12 is a 0. So let's just say, for this instance, the PLC sent it a 0 for some reason. So we're acting like the GI2 is coming from the PLC. So let's say, I was given the example of a small box or a big box. We can only stack 5 of them there, and then a big box we can stack 10. So these are coming from the PLC, and then, you know, I'll just go ahead and write this out real quick. Edit command, or not edit command, instruction, register equals register. Okay, so we'll do register 5 is equal to register 13. I'll use this one up here, which is our GI3 sim. Okay, so now if I come back up here to the top again, shift, forward, yes, forward. Now we go look at our data. You can see that 5 and 10 data has been shoved over here to pallet 1 and pallet 2. Okay. And so I can change these numbers to whatever, and then if we run that code, it'll change these numbers to whatever, right? Yeah. To the same. So in this instance, like what the example is when I said recipes, that the PLC would send a value. Like again, if pallet 1 needed to be big boxes, it would send the robot a 5 for big boxes, because we're only going to stack 5 boxes of big boxes. And the PLC would send it a 10 for medium boxes, because we're going to stack 10 high for medium boxes. So if you were to switch this jump label with this label, okay, so now we're going to pretend this is jump label. You would run through this code, you'd get to here, it would say jump to label 10, which means it would jump all the way down here. And so you skipped all this code. It says boop, and jumps right past it. Boop. So you're jumping past lines of code. Whenever you jump up towards something, whenever you jump from the bottom to the top, it's generally for a loop. If you're jumping from the top to the bottom, you're generally jumping to different portions of code, or skipping portions of code, one of the two. Okay, so now we're gonna go ahead and finish out this one here that you were doing, that you're saying if it's a full pallet, jump to label. So we don't know where we're gonna jump at yet, but let's just go ahead and add a generic label down here at the bottom. So instruction. When I say generic label, I mean we don't have a purpose for it yet, but we need to create one to move forward. And then just make it, this is at the very bottom of the program for right now, so just like make it 90. As I mentioned before in other videos, that your labels closer to the top, I generally will do them at like 10, and I will do other labels down at the bottom at 90. If for some odd reason I think a program will be extremely large, then I might do 100s. So I'll have 100, 200, 300, 400, 500. But I generally only do that on a very, very large program. Yeah, I mean, it doesn't seem like we're writing code to do like one little pickup thing right here, right? You have a pickup, you have a place, and this is just for one part number. What if you have 10 part numbers? So you created the first part of the program for pallet 1. So we're basically just going to reduplicate what we did for the pallet 1 for the pallet 2. Okay, so we're going to start off with just this if statement. Okay. So go instruction. Number 3, if. Okay. And then this one should be if equal, yep.
This one? No.
Yep.
Okay.
So if register, yep. I think we used 3 the first time, so I think this one will be 4. No, this one will be 4. Equal, yeah, enter. Register. And then this one I think was 13. Or no, it was 13, it was 6. I think so.
6.
Oh, yep, no, I was wrong. This one should have been register, it should have been 3. You had it right the first time actually. So just hit previous. Or go ahead and just finish it out. It'll be easier if you just finish it out and then change it. They're kind of weird when they're halfway through with editing one of these. It's better you just like finish it out or start over, one of the two. Yep, jump label. And then this one will need to be a do 99. Okay, and then go ahead and change your if. It should have been 3. Your first register should have been 3. Yeah, pallet 2, and then that should be 5. Yeah, 5. Yep. So if the number placed on pallet 2 is equal to whatever we're saying the full amount is, jump to label 99. Okay, so next you just need to go ahead and go down like one line, and then you need to like record a couple positions. So go to position, hit your little next button, yeah, that one. Position, joint is fine. Yeah, just do a joint fine. It's okay. And then go ahead and like shift and then jog down -Z. Okay, actually hit the shift button again. Hit the coordinate button. Okay, see up there at the top, it's telling you what frame you're in. Joint or world, right? So now you're in world. World, member gives you the triad, and you move in a linear motion. And you can see it directly from the robot right now. X is this direction. And so you'll use the right hand rule, which the right hand rule means you do your hand like this, and then you point this finger away from the face of the robot, or the way away from the front of the robot. X direction, X positive will be away from the robot's base in the front, and then Y positive will be to the left of the robot's base, and then Z positive will be up from the robot's base. So we can see the same thing here with this triad. This is what would be considered the front of the base of the robot. So your right hand rule should always go like this. So like this to match, and you should face, like, so I'm turning my hand like this because that's exactly how it should be. You know what I mean? Because that's where the face of the robot is, right here. And you can see it right here too. See, it tells you, see how there's a Z positive, X positive, Y positive. So I can grab this, move it. Okay, now we'll just record a second point there. Just make it a fine, we don't really care about that right now. And maybe we'll do a third point and make this go in a little bit. The math function, which the math function will be your register equal to register plus. Hit your next button. Instruction. Yep, registers. Yep, and then you want number 2 equals to. So register. Yep, first one. This one was 3. Yep. Again, register. 3. So this is just the way you increment up in a robot. Enter. And then 2 for the constant. And then make it a 1. Yep. And then enter. Okay. So now you created your increment. So this is going to increment your register 3.
On the last one, this one was 5, right?
Nope.
Which one was it where if you reach 5, you start over to 10?
That's your full register. So going back to data.
Okay.
Where'd our mouse go? There it is. So going back to data, full pallet 1 was 5.
Okay.
And that's just a hard set value. We're not changing this value. We're just saying it's set.
I got you. Oh, okay. No, number 10 is the second pallet is 10. If it's full, is 10. Okay.
Yep. Yep. And so again, like for this example, we're saying 5 would be a large size box, so you can only fit 5 of them on a pallet.
Okay.
10 would be the medium sized box because you can only fit 10 of them on a pallet. And then for a small box, you could fit 20 of them on a pallet, just for example. Well, now we're not doing that example now, but with the 20, but to follow that same concept. So now you have the math. Go ahead and go down. There's one thing that you're still missing from this program. A couple things actually. So then you need first thing you need is your label 99. So up here in line 22, you're jumping to label 99, but you don't have a label 99. So you have to create a label 99. So instruction. Label, number 5. Label, yep, 99. So we will basically be doing a skip. So whenever this if statement happens, you'll say if register 3 is equal to register 5, aka you have a full pallet, jump to label 99.
Is it skip?
We're using it as a skip because we're going to skip past all this logic,
Okay.
right? It's still the instruction, it's still jump label, but how you're using it is how we're kind of saying, yeah. Yeah. So now we're going to go, so jump label, so it's going to jump to label 99, and then, so now we're going to do instruction, and we're going to add a jump. Yep. And then we're going to go jump to label 90. And the reason for that is because we wrote all this code right here, but we don't have a loop. So whenever you say jump to label 90, you're gonna jump back up to here again. And then you'll run through this code. And then it'll jump back up to label 90, run through this code. Okay? So, let's go ahead and run it. Shift forward, yep. Just hit no. We'll go ahead and go back to the top. Let's go ahead. Or do you just want to run that bottom one? So I want to add something here because something that we're not doing in this first part of this program, 2 lines, is we're not setting our registers equal to a 0, meaning so I'll just do it and then I'll explain it. Register and then 2, set it equal to a constant, 0. Instruction, register, 3, constant, also a 0. Okay. One thing I'll point out here too, just for being symmetrical, I actually should have put 2 and 3 above 4 and 5. So that way it'd be 3, 4, 5. Just for number's sake, like keeping things nice and in a pattern as much as possible, the better. So that's one thing. The other thing is too, this top part of this program above label 10 is known as the init part of the program, initiation part of the program. So whenever we're gonna start this program for the first time, we're gonna take the values from our PLC with our generic simulation registers that we have here. We're gonna then also set the number of parts that we've placed to a pallet to 0, right? Because we're assuming that we always start out with new pallets with nothing on them. So this will automatically wipe out the numbers. And part of the reason for that is like if you look, there's still a 5 inside of pallet 1. So if we run this code, it's immediately gonna skip pallet 1 and go to pallet 2 because it's already equal to a 5. And that's what our full number is. Okay, maybe that's how you want it to act, but in this instance, we're gonna act like that's not how we want it to act. So we'll run through this init program, or we'll run through this program. The first part of it will be a init, and I'll almost always add a comment that says init at the top, or I'll have a separate program that is the init program. Yes, forward, forward, forward. Okay, we'll look at the data to see what happens. So you can see it zeroed out those, and these values are still the same because we didn't change the values down here. So this is where it's grabbing the values. But let's say, for instance, the PLC updated some different values. Maybe you're doing 2 medium-sized pallets or two large-sized pallets. And so it made 5 and 5. It would have updated that into here as 5 and 5.
Okay.
If we're pretending the PLC gave it some data. But we didn't do that, we just left them the same values. So now just kind of running through here, boom, 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 where what's gonna move. Speed them up a little bit. Especially doing forward, I don't care about the positions. Now if I was gonna run this in auto, I'd slow it down so I could actually see the robot moving and see the code run a little bit better. But also if we're not forwarding, we won't see any of this. Like as soon as when it does do a register or the math right here, it'll instantaneously, takes milliseconds to scan through code. It only takes motion time. Pallet 1. So we're still on pallet 1, right? So that part just did exactly like it was supposed to. We're still on pallet 1. And if we look at our data, pallet 1's incrementing, yep. Okay, now we're at pallet 2. So let's go look at our data. You see we have a 5 here and a 5 here. So that's why it moved on to the pallet 2. Oops, I didn't do that. forward. So now I jump back up to label 90 for pallet 2. See, we're running pallet 2 here. Look at our data and just see how it's changed. So we've ran 2 pallets, or 2 parts on pallet 2. Data, or not data, select. Okay. So I think that would be 4, right? I think this one's 5. Let's just check the data and see if it is. Oh, this one's got a lot to run. We're going up to 10 on this one. So we gotta run through this one quite a few more times. I'm gonna kind of run it through as fast as I can until I get closer to that 10 value, then I'll slow down. I'm gonna be at like 8 or 9. So we're 8 now. And we're back starting at the top, so we haven't done the math yet. So when we run through the math function, now we're at 9. We'll run through it one more time. This should be at 10. Now see, notice I'm stopping right here because we just did the math. I want to go look at the data first. Okay, 10 and 10. So the data looks right. So now when I go back, it should execute the if statement. So here's the if statement. If place pallet 2 is equal to full pallet 2, jump to label 99. Good. Then jump to label 99. And then from here it ended the program. One other thing to keep in mind, no robot program ever ends unless it's set up in a way where there's something that restarts the robot program. But almost always the robot program never ends, it just runs in a continuous loop. And then it's just commanded to do different stuff off of that one loop. So if the robot's not being commanded to do something, then it just sits there and just keeps scanning in the loop. Waiting. Oh, PLC said part present, go. And that will trigger the signal for the robot to go pick. Okay, now for this logic to work, go ahead and scroll down a little bit. We have to add the math, okay? So after your positions, so like line 18, go ahead and go up to line 18, and we're gonna add the math, which will be like a register equal to the register plus 1. So instruction, registers equal to. Actually, you don't want it to equal to. Hit previous. You want number 2 equals to plus. Okay, so register.
Oh, this one? Oh,
yep. What do we use for this? 2. We use register 2. If I'm not mistaken, it might be enter.
Register again?
Register again, yep. 2. Plus a constant. 1. Enter. So this math right here will increment up 1 every time we run this program. Okay.
So I kind of see some similarity with the PLC a little bit. When we were doing like I forgot what it was, but like the timing. When we were doing the timing, they would create a loop. I remember one program they were doing like a timing where after they done that amount and then the timing will change. I forgot what exactly it was, but I know I see something kind of slightly similar to
maybe
PLC.
So like the PLC, you use a counter.
Yeah, okay.
And then you usually use like the done bit of the counter.
Okay.
I like people to learn robot first because robot is easier because it's linear code. It scans right through. You can literally just go do, see what it does. There's not really an option to do that in PLC. The only thing you can do in PLC to kind of do the same thing is to like force on inputs, force off outputs. And then generally everything moves so fast that the only way you can see what the program's actually doing is if you put counters in there. And then you can see, okay, that did that one time, that did that one time, that did that one time. Okay, all the things executed like I thought they were going to. Okay, so this is going to be the addition math that's going to count up. So go ahead and go back up to the top of the program. So what we have right now, but as of right now, we're only stacking to like one pallet.
Okay.
Because you only have, you know, the positions maybe for one pallet, and you only have the registers for one pallet.
Oh,
So right now we're only doing the programming for the one.
Okay.
So now we're going to trial this and see if it works, and then from there we can do pallet 2's logic. So we'll just kind of forward through this program. Yep. Shift forward. Hit yes. Enter button. You gotta forward through it. It won't matter because you're forwarding.
Oh, okay.
That's one of the nice things about forwarding is you can see everything that's happening.
Okay.
So you always want to like forward through a program if you're testing it to see how it's going to react. Unless you just have already reached like an experience level where you feel like, okay, I know what this is going to do.
Okay.
So boom, now you're in the main loop. So you've seen it just jumped up there back to the top again.
Mm-hmm.
Right? Okay, let's go check out the data, see what the data says. Click your data button. Yep. Okay, go up to your register number 2 that's up there. Okay. So you can see it incremented up 1. Number of placed pallets.
What do you mean?
You see your 1 right here.
Mm-hmm.
You placed one part.
So, what are you supposed to be?
Huh?
What is supposed to be?
This is what it's supposed to be.
Oh, okay. I thought you meant like, okay.
Well,
okay,
how many cycles have we ran? Right, we ran 1 cycle.
1 cycle. Okay.
So this is incremented up by 1.
I got you.
Okay. So now we'll just go back into the program again, and we'll run some more cycles. So we know we should reach 5, right? Because that's what this full pallet 1's telling us is 5. So like, let's just run through this thing, and let's run it to 4. So like 3 more times. So that's exactly what you're wanting to do. Like if you don't know what it's supposed to do, or you're trying to learn something or see how something's going to react, you just keep going back. You just keep trying. You keep running the logic and then seeing what the data tells you it's doing. Okay, so let's go ahead and run through it again. I think we were on 3, so this will put us at 4.
Okay.
Oh, you're not running through it. Yeah, you gotta forward through it.
So in this one, you go step.
Yeah, you're already in step. Hit forward. Yep. No. Yep. Okay. Forward. You should be at 4 right now.
Yeah.
Okay, just forward.
I'll go forward again.
Yep, keep forwarding. Yep. Now, after you get down to the bottom of this one, go slow. Okay. Again. Okay. Now, go check your data.
Oh.
It's a 5. Okay. So now we're going to go back to your program. If this part works correctly, it should execute. Okay.
Okay.
So just forward through slowly. Forward. Okay, do you see?
Yeah, sure.
So now we jumped out and jumped to level 99. Maybe this pallet's full, so now we need to fill up the next pallet.
Okay.
Okay. Or it might be wait till new pallet, present, or whatever the next sequence in the process is. After you've written something like this, and you let's say you've gotten it proved out, one thing that you can do is you can just copy and paste it, or you can re-handwrite it all. This is not a lot, where like maybe just re-handwriting it makes sense. Or you can copy and paste it, especially if it's a lot of logic. The one problem with copy and paste, and why it's kind of frowned upon to copy and paste, is because there's a lot of things that are inside of here, like this register 2, this register 4, and if ever you forget to change one of these numbers, and you should have changed one of these numbers, you've now created a bug in your logic. And it'll do the thing, and you'll be looking at it, and you'll say, well, I don't understand, why is it not doing the thing that I want it to do? And then like after like an hour of trying to figure it out, you go, oh gosh, dang, I forgot to change that to a 5. You know what I mean? So that's why it's frowned upon to copy and paste. As long as you're just meticulous about it, and like that you make sure, like if I copied and pasted these, maybe I would even have, like I'd write a note saying, okay, I copied line 7 and 8, or I need to change the values on 6, 7, and 8. Or in this instance, I just need to change the value on 6. So I need to change the values on 6, so I'll make that note. And then I'll make sure that I come in here and I change all the values on the things that I need to change the values on. One other thing else to note here in the program is just that this position was never ran. We never ran this position. We're at this position because it's recorded as the same position as this position. They're both a position number 3. Right here, both position number 3. But we've actually never executed this position because we either jumped back up to the top, so we ran the code, jumped back up to the top, or your code just executed and we jumped to label 90. So if ever you wanted to get to this position, you would never get to this position because there's nothing to get you in between these two instructions. If for some reason you wanted to run this point independently, you can add one more label above it. So like, let's use an example instruction. No, not instruction. Edit command, insert 1, 3 lines, boom. So I've added some lines there. And then edit command, 1 instruction. Again, good programming practice to always create segregation between instructions that don't go together. And I actually have too many lines here. So too many lines is bad too. You don't want big gaps and things. I always like have like, depends, the amount of lines I have segregating something is how chunked the code I want to make it. Step, shift got me again. Okay, so I'm gonna add a label here. Boom, and let's just say we're close to the bottom of the program. Maybe we'll make this one 80. Because we're close to the bottom of the program. Again, nothing jumps to label 80 right now, but we could create a jump label that or some instance that makes us call label 80. And see, like right here, we have too many spaces. So if I was to come back here and clean up the code, I'd come back here and I would just say like edit command, delete, and then I want like maybe 2 line space there. Oh, there's too many lines. Edit command 2. So now this code is like, I'll say it's cleaned up better. To where things are like more organized.